So for the next video, we will discuss the summary of Chapter 11 entitled Small Network Topologies. So the majority of businesses are small. It is not surprising then that the majority of networks are also small. A typical small business network is shown. Then with small networks, the design of the network is usually simple. The number and the type of devices included are significantly reduced compared to that of a larger network. The network topologies typically involve a single router and one or more switches. Then small networks may also have wireless access points, possibly built into the router, and IP phones. As for connection to the internet, normally a small network has a single one connection provided by DSL, cable, or an Ethernet connection. Managing a small network requires many of the same skills as those required for managing a larger one. The majority of work is focused on maintenance and troubleshooting of existing equipment, as well as securing devices and information on the network. The management of a small network is either done by an employee of the company or a person contracted by the company, depending on the size and the type of the business. Device selection for a small network. In order to meet user requirements, even small networks require planning and design. Planning ensures that all requirements, cost factors, and deployment options are given due consideration. When implementing a small network, one of the first design considerations is the type of intermediate devices to use to support the network. Then, when selecting the type of intermediate devices, there are a number of factors that need to be considered. First one is the cost. The cost of a switch or router is determined by its capacity and features. Then the device capacity includes the number and types of ports available and the backplane speed. Other factors that impact the cost are network management capabilities, embedded security technologies, and optional advanced switching technologies. Next, speed and types of ports interface. Choosing the number and type of ports on a router or switch is a critical decision. Newer computers have built-in 1 gig NICs. 10 gig ports are already included with some workstations and servers. While it is more expensive, choosing layer 2 devices that can accommodate increased speeds allows the network to evolve without replacing central devices. Next, expandability. Networking devices come in both fixed and modular physical configurations. Fixed configurations have a specific number and type of ports or interfaces. Then modular devices have expansion slots that provide the flexibility to add new modules as requirements evolve. Switches are available with additional ports for high-speed uplinks. Routers can be used to connect different types of networks, and care must be taken to select the appropriate modules and interfaces for the specific media. Then the operating system features and services. Depending on the version of the OS, a network device can support certain features and services such as security, quality of service, voice over IP, layer 3 switching, network address translation, then dynamic host configuration protocol. IP addressing for a small network. When implementing a small network, it is necessary to plan the IP addressing space. Then all hosts within an internetwork must have a unique address. The IP addressing scheme should be planned, documented, and maintained based on the type of device receiving the address. Examples of different types of devices that will factor into IP design. End devices for users, servers and peripherals, hosts that are accessible from the internet, then intermediary devices. Each of these different device types should be allocated to a logical block of addresses within the address range of the network. So now we're done discussing the summary of Chapter 10.